everyone, I'm Alessandra and I'm here today to welcome you to the very first episode of People Also Ask and We Answer, the new interview series by Clearbox AI. I will introduce our guests right away, but first of all, I would like to explain to you what this title is about. Depending on our guest expertise on AI, we try to answer the most researched questions on the topic on Google. So today we're going to talk about how to ensure trust between humans and machines with our two guests. Luca Gilli, CTO at Clearbox AI. Hi, Luca.
Hello.
And Tim Schrills, psychology engineer at Lübeck University. Hi, Tim. Welcome. We are very happy to have you here today.
Hello, thank you very much for inviting me.
Tim, maybe you would like to introduce yourself and tell us about your current research.
Yeah, I'm happy to do so. Yeah, I'm Tim. I'm from Germany, and I studied psychology and computer engineering, and my research is focused on exactly this interface between psychology and computer science in the human AI interaction. So what do humans need to interact with AI, and what does AI need to deliver to make humans able to interact with them? Currently, I have different research projects going on where we look into the interaction between people and intelligent systems, and how we can design the interfaces of these intelligent systems to lead to an efficient, trustworthy cooperation between those two partners. And we are working in the field of automotive and energy, but also, and I'm really love to work in this field in the medical field and medical AI systems.
Okay, perfect. Very interesting. Thank you. So let's begin with the first question, which is, how does explainable AI work and why is it important?
I would like to start with some kind of definitions, because in my opinion, explainable AI is a very broad connotation. It can mean a lot of things, and sometimes it's also a bit misused. So let's start with the definition of explainable AI. Explainable AI means when we talk about artificial intelligence, usually we talk about an intelligent agent, which is designed to solve a specific problem, a very specific problem, which can be, for example, from finding the best way to vacuum your room to translating a text from English to German. So when we talk about explainable AI in this context, we really mean, given that our agent come up with a solution, what is the explanation for this solution? And it can be like, okay, I decided to use AI to design an antenna. This antenna came out with a very strange shape that apparently is very efficient. Can this algorithm explain why this antenna is shaped this way? However, right now, especially in academia, with explainable AI, people tend to mean a subfield of this concept, because we are talking mostly about machine learning, supervised machine learning. We are talking about interpreting machine learning models. So the reason is that during the last 5-10 years, there was an explosion in popularity of deep learning, of neural networks. And these techniques come with a lot of complexity. And of course, there is a need for interpreting and explaining this kind of models. So with explainable AI nowadays in academia, we really mean interpreting machine learning models, even though it can be a bit broader. But it is a very important concept. So it's a very complicated issue, because these models are getting more and more powerful and more opaque, difficult to understand. And of course, there are different ways to approach the problem. One can try to work on, for example, interpretable models by design. So instead of working on models which are very accurate and very performant, they can develop models which are as accurate, but trying to make it interpretable by telling them to provide an explanation every time to make a prediction. Or you can also extract explanation post hoc. So given this model, which is very performant and is behaving very efficiently, can I extract explanations with a certain set of techniques? And one can be more interested in the global analysis. So this model is, why is this model behaving like this on a global scale, or more locally? Why is this prediction decided this way instead of the other way? And there's a very set of techniques which is literally exploding. Like every day, there's papers published in academia, especially about about this, how to deal with this kind of explanations. One thing I would like also to talk about, especially because Tim is here and Tim is an expert of human-computer interaction, is that one thing is to generate explanations. So there are techniques, mathematical techniques to generate explanations. Another thing is to make people understand these explanations, which is a completely different issue. So for example, you design interfaces, you might correct me, but you design interfaces to create this kind of bridge between explaining and understanding models. And the reason why you need to, also going back to why is it important, there are several aspects that need to keep into consideration. Like it's important, for example, for developers while developing a model, because by knowing why the model is behaving a certain way instead of another, you can create better models. So it's a way of driving the development in an efficient manner. But also when you have models that are working in specific contexts, especially when you have humans interacting with these kind of models, for example, when you're talking about a decision support system, in this case, explainability, interpretability plays an important role, because as the title of this interview says, it increases trust between the human and the model. But as I said, it's really important to create this bridge between the explanation and the end user, and this bridge is done through interfaces, so through this human-computer interaction.
Okay, thank you. So Tim, can you tell us how does it all relate to designing human AI interfaces?
Yeah, I mean, when we speak about designing human AI interfaces, I would like to broaden our perspective. We design the whole interaction. So it is not only about rearranging a few pixels, which is an important factor, but it is also, what questions can I ask to a system? What does a system inform me about, and which information does it deliver to me in which way? And when we try to make people able to cooperate with the system, this is crucial for us to understand how do they understand the system? How do they understand what the system is doing? So let's give me an example to you. Yeah, I have type 1 diabetes. And there's a modern technology where there are smart insulin pumps or smart systems with an insulin pump, and they can, from the glucose level that you have at the moment, they can calculate how much insulin you will need in this specific moment. But for that to work, I need also to deliver some information to the system, like how is my activity, what is my food intake, and so on. And for me to make this correctly, to interact and to cooperate with the system correctly, I need to understand how the system is processing this information. So I need to show to the user, okay, your food intake is very important because this will make the system behave differently. And this information is, for example, too complicated for the system, or the way you want to communicate it to the system does not work for the system. Or on the other hand, sometimes the system maybe gives back some information that a user cannot use, and the user needs additional explanation how the system came to this conclusion. So when we design for interaction between humans and intelligent systems, explanations are our way of making this collaboration effective, efficient, and yeah, basically trustworthy for both partners, because they know which information is processed in which way, they can anticipate it, and they can design their own behavior, change their own behavior accordingly. This is a crucial thing for automation for many decades, nothing new for AI, but a special challenge in AI because of the things that Luca already explained, more opaque techniques that are developed, and we need to find solutions for exactly this piece of technology.
Okay. Thank you. So let's go with the second question. What is a black box in machine learning?
Well, it's becoming a very hot word. It's because of the issues we mentioned so far. Basically, with black box machine learning, we talk about all the situations where we have a model and we are not able to understand its inner decision processes because of the reasons mentioned so far. For example, we are dealing with a deep neural network, and the network is so complex that we don't know why it came up with a certain decision instead of another. It's a concept that is becoming more and more prominent for different reasons. Mostly because, for example, in the past, when talking about machine learning algorithms, there used to be a lot of handwork involved. Maybe for computer vision, you were supposed to do a lot of feature extraction by hand. Engineers were supposed to design a way to, for example, tell an algorithm in an image how many corners are there, how many edges are there. And right now, deep learning is taking away this job from the engineers and doing this kind of extraction procedure all inside. And this creates a lot of potential because it really can scale up the amount of information you can extract from data. On the other hand, is creating a lot of issues about the complexity that arises from this kind of approach. We can talk about black box in two main circumstances. So when developing a model, as I said, it can create a lot of problems because I don't know, you might have heard about all these huge natural language processing models like GPT-3 that requires months to literally weeks and weeks to train, and it involves a lot of energy consumption, computational cost, and so on and so on. So if you are able to understand why a certain architecture would work better than another architecture, or maybe detect that a part of your architecture is not really needed for performance. So maybe you can, through explanations, you can understand that 10% of the network is not really that important for the final outcome. You save 10% of the training cost, which projected in this context of weeks of training or tons and tons of CO2 really emitted because of this training can have a huge impact. The other part is really about using models in real life, because these black models, once developed and put in production, they need to be used by humans. They need to be put, maybe held accountable for their decisions. So there is a lot of issues arising to the black box problem. For example, in terms of bias, you have to make sure that a model is not biased against a certain segment of population instead of another. And if you're not able to understand what's going on inside the model, this might be tricky also to keep under control. And as I said, as also Tim said before, in a decision support system, the objective of a decision support system is to make a process more efficient. It's not just for the sake of it, but you want to have a model that, for example, would help a clinician to speed up the number of prognosis or diagnosis that it performs during a day. But if this model is slowing down this process instead of making it faster, because maybe the clinician doesn't trust the prediction, he goes back to his own judgment, he discards a few of them, the threshold between an efficient model and a model that slows down your processes is very narrow. It's really important to deal with this issue. Black box machine learning is a program that affects several stages of the machine learning life cycle, and especially the last one. So the human-computer interaction is also very, very important, because you can make in terms of AI adoption, it can really determine whether machine learning models will be adopted in a field or not.
Okay, thank you. So let's go with the third question. Where is explainable AI most used?
I mean, I think it would be interesting to answer this question on two levels. Like, where is it used at the moment, and where should it be used? Yeah. Mm-hmm. My feeling is that a huge portion of the research that is done in XAI is still focused also on very technical users. So, like Luca said before, XAI is able to support users, like developers, for example, identifying problems in the model or in the algorithm, supporting them to fix them, or to understand from which data problems or missing data or incomplete data does this come from, and so on. And this is, from my perspective, one major application that is developed at the moment. And when we look more into end users or products for people with less less education in computer science, then I think most of the people will have seen some kind of explanations from AI systems already in recommender systems most of the time, I think. Like when you see in a music service, like Spotify or any other music services, and you have seen, okay, you get this recommended because other users have seen the same, or because you have seen this item before. This is already a kind of explanation that is used. Or sometimes when you want, for example, to make some kind of calculation, maybe for a mortgage or something, there is sometimes already an AI system behind that informs you, like, okay, your score would have needed to be like this for you to be accepted or for this credit to be declined. But where we really need to use it more, from my point of view, is, for example, in the field of medicine or in the field of personal health care, where personalization would have a huge impact on what we can do. So health is a very personal topic. And for example, we have some projects going on also in the field of nutrition, and personalization there is super helpful and can inform people, but they also need to understand what they are doing and why they are maybe getting some recommendations on behavior or getting feedback for their behavior. So, and what I think, and maybe I can also reflect a bit on the black box question that Luca was answering. I think we have different issues and we need to have XAI tackle them. And one of them is, of course, people need to rely on XAI, need to know it is trustworthy, it is reliable. That is very important for the medical sector. We have the topic of fairness, which is, for example, like when you're scheduling shifts or something like this, super important. When you do like application sorting out, extremely important. But we have also a big chance that we should not miss. And there, I think this is the point I really want to make, where XAI grants us a huge chance. This is also that XAI can help us understand things. Like when I am having my diabetes treated by an AI, this AI can not only treat it, but it can also tell me, okay, you really need to be cautious in the morning. And you could improve so much when you would eat less there, or when you would get more insulin or do some activity in the morning, because those are your best days. And this is a huge, huge chance that we have. But when there are black box models, then people have no access to the knowledge that they generate maybe by their own data. And so I would say XAI is used the most at the moment for developers to fix models and so on, but it has the hugest impact maybe for our society when it makes people trying to understand their own life, behavior, and actions.
Perfect, thank you. So this leads to our last questions for today, which is, how is explainable AI used in medicine, and what are the main challenges?
I think it's, as Tim was saying during the previous answer, it's really important to start using explainable AI in medicine, because it's a very sensitive field where the increasing trust between models and humans would really make a difference. There's right now, as I agree with Tim, that right now it's used mostly for debugging models. So because it allows you to efficiently detect problem with the models. For example, if a model is not generalizing properly, or is overfitting, or there is data leakage. So if the model is behaving stupidly, explainable AI can really help you detect this kind of misbehavior. On the other hand, I think there's still a big gap about using explainable AI in human-computer interfaces, because as I was saying, it's a topic that's really growing a lot in these years, in these months. There is really a plethora of techniques to try to explain models. There are techniques that are, as I was saying, more based on local decisions, techniques that are more based on global model behavior, techniques that will require really to open your model and start digging into the neurons of your neural network, and others that are a bit more agnostic. But the problem with this kind of techniques is that there's still a lot of work to be done in terms of personalizing this kind of explanation to the very specific context. Because first of all, different people can understand different information. Not every end user can digest the same information you feed him in terms of trying to explain a model. That's a problem because then you need to find a way to tailor this explanation to the end user. So a model that should serve a doctor is different from a model that should serve a nurse, that's different from a model that should serve an engineer, for example. And this creates a lot of customization that, and in my opinion, is not really standardized yet. And also in terms of methodologies, there are still a lot of issues about finding robust ways to explain models, because quite often I noticed also in right now in big data science or machine learning platforms, there is a lot of tooling about explainable AI. These tools and these libraries require some knowledge about the explanation techniques themselves, because you need to calibrate the explanation. Basically, you need to tune it to the specific, not only problem, but also to the specific model, to the specific type of data. And this is often neglected. So sometimes you end up having, tools that output explanations, but these explanations are not really, first of all, robust. So they might, for example, you have two individuals which are very similar and two completely different explanations for the same decision, because maybe a small change in this individual property is really affecting your explanation output too much, and it's a problem, because then you really lack of robustness. So I think there's still a lot of work to be done in terms of from a methodology point of view on making this kind of process more robust, but also from the design point of view, because then you need to really find maybe a design pattern to say, okay, this kind of problem is most suited for this kind of explanation, and this kind of explanation comes in two different ways, and even in this case, teams and teams colleagues' work is really important.
Thank you, Luca, for going first, because I had a hard time thinking about how to cap the answer a bit, because this is such a big question with I could, I think, talk hours about it, but I would try to stay a bit focused. So first, I agree that still at the moment, XAI is mainly a debugging tool when we speak about medicine. And this is also based on the fact that, of course, and for a good reason, the skepticism and also the hesitation to use intelligent algorithms in diagnosis, in operations, in therapy decisions is large. That a recommender system that recommends you a song makes an error is maybe not such a big deal. You wasted 2 minutes of your lifetime listening to some song you didn't want to hear, but you don't want an algorithm to make a mistake in diagnosing some disease that you may have or have not. So there's, of course, to build trust in such an algorithm requires much more effort from the developers than in many other algorithms. Also, the data that we use here is way more sensitive. We need to be way more cautious which data we can use for explanations and which one not, because we cannot just easily handle medical data as maybe different data before. So there are more challenges to use AI in medicine, and XAI is definitely needed, in this case, more needed, and it needs to be way more tailored to the people who are responsible to use it and responsible to collaborate with the system. So to have an XAI algorithm that helps a developer to debug, to understand the model, to support the model, and to further the model is very important to make us as a society get better algorithms. But we need XAI that enables patients, doctors, nurses to understand what they are actually doing and how they are using the smart algorithms, the intelligent systems to support their work and to make decisions that affect not only their own life, but maybe another life too. And here it is important that we understand which questions do those people have, which problems do they have, what do they want to understand and know about algorithms? How would they try to get an answer? So we had one project where we really went to the doctors and we told them, okay, tell us, if you could ask a question to the algorithm, what question would it be? Mm-hmm. And XAI is exactly that, answering those questions to give people the chance to find out for themselves if the algorithm is trustworthy enough, if they understand it enough to use it, and if they would use it in such a sensitive manner as medical diagnosis or operation maybe. And I think that's the main challenge, to give people the chance to collaborate with AI rather than just use it as one tool, but really to make them understand this is something I can work together with. I can question it, can understand it, I can make it prove, or at least give me hints on why it decided that way. And this is the main challenge we have in all AI systems, but in medicine, because of the things I mentioned before, we have it especially. And we need it also, I think, to make it easy for people to do this job. So there is no doctor or nurse or anybody else in the medical field who wants to dig many hours into computer science stuff and maybe check out how to make a little bit of code to get answers to those problems. It needs to be easy, controllable. And I want to address my question as easy as possible to the algorithm. So when I say, okay, why did you give this diagnosis? I need to get a fast and easy answer for me. And this is the main challenge for XAI in medicine especially.
So thank you very much for your precious point of views. I think they can be useful not only for the people who ask for these particular questions, but to all the people interested in explainable AI. So thank you for being here with us today, Tim. It was a pleasure. And I hope to see you soon again. If you want to stay updated on the next episodes of People Also Ask and We Answer, you can follow us on our social media profiles at Clearbox AI on Twitter and LinkedIn. Hope to see you soon. Thank you. Bye.
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 Goodbye.